In any reaction where we start actually mixing compounds together, you've got the reactants, the stuff that you'll start with. In the demo that I started before this video, sorry, you people at home are missing it, but were sulfuric acid and sugar. The products will be something different. It'll be what's created by the reaction. And we're going to be talking, it's a yield sign that gets us from one to another. Now, the demo is cool. The rest of it's not very cool. One of the things of chemistry, the basic thing we have to be able to do before we can move forward with investigating all of the connections from what you start with to what you end with in a reaction is we have something called the conservation of mass, the law of conservation of mass. And it states something very simple. Look here. The total number of stuff you start with on the left-hand side has to equal the total number of stuff that you end with on the product side. You can't create or destroy matter. You can't create or destroy mass. So it's really important that if you have 6 hydrogens on the left, you've got to have 6 hydrogens on the right, because that's what will happen physically when studying matter. Let me show you why I had to make this distinction, and we can actually run into problems. Write this down. This says hydrogen reacts with oxygen to produce water, dihydrogen monoxide. Look at the oxygens on both sides. All right, now when I say both sides, we're divided by the yield sign. All right, the yield sign is what divides reactants from products. I'm telling you, you need an equal number of reactants to the products. Do you see the problem with the oxygens? There's 2 over here and 1 over there. That can't happen. Your job is to do what's called balance it, to make sure that we've got the same number of everything on both sides. And this short cheat sheet I gave you is the exact procedure to do so. But first, we need a little bit of terminology. What are these little numbers called? These are called subscripts. All right. Now, we've been dealing with that for a long time. All right. I'm going to introduce a new type of number to you today that we've never used. It's a big number. Like if I were to put a 7 right here, which is not the number that would go there. But do you see how my 7 is much bigger than my little 2? Big numbers that show up in front of entities, in front of lone elements or compounds, these guys are called coefficients. Here's the biggest thing I need you to understand about balancing equations. You cannot alter, add, or remove subscripts. We can't touch the little numbers. In other words, looking at this original equation before I added that 7, where we said, well, there's 2 oxygens over here and only 1 oxygen over there, some of your brains would falsely think, well, if you just put a 2 there, now they're the same. Now there's 2 oxygens there and 2 oxygens there. You cannot mess with subscripts. The only way that you can balance equations is by adding coefficients. You can add big numbers in front of the entities, and the big numbers will multiply. Again, this 7 is a totally false number, but how many hydrogens do you think there are if I had a 7 there? There's 14. It's a multiplication process, all right? How many oxygens are there if there's 7 H2Os? 7, because 7 times 1 is 7. And we're about to get plenty of practice with that. Now, if you graffitied your example by writing all this stuff I just wrote, then rewrite it the original equation. That's fine. Just rewrite that if you need to. We can only add coefficients, the big numbers, in front of entities. So we can put a big number there, we could put a big number there, or we could put a big number there. You can't try to put a big number in the middle of a compound, in other words. But when you add the coefficient that we'll use to balance it, it affects the entire thing that it's in front of. Just like a moment ago with my 7, it made there be 14 H's and 7 O's, because a coefficient will affect the entire thing that he's standing in front. So with this in mind, let's balance our first equation. Look at your new cheat sheet, and it gives you the process. Step 1, work with me. It says list each element that is found on the reactant side. All right? What are the elements on the reactant side? H and O. All right, remember, the reactant side is everything to the left of the arrow. Whoops. The reactants are to the left of the yield side. Let's go to step 2. That was easy. Step 2 says duplicate that list beneath the products. Now, the products are everything to the right of the yield side. It says duplicate that list. H's and O's. Hey, we're technically halfway through the process. There's only 4 steps. Step 3, count the number present of each element on each side. Okay? How many hydrogens are there on the reactant side? Everybody see where that 2 comes from? How many oxygens are there on the reactant side? If I write down a number you don't get, you're not the only one. Yell at me. Cool. Let's do the product side. Let's go to the other side of the yield. How many hydrogens over here? How many oxygens? We cool? Now listen, we're multiplying. When we add these big numbers that we're going to add, we're multiplying. When you multiply, numbers get bigger. The reason I point that out is my hydrogens are good right now. The whole point is to make the elements have the same number per element. My oxygens are not. Since I'm going to make numbers bigger to fix it, which number do you think I'm going to alter? The 2 or the 1? The 1. We're going to make the 1 become a 2. And here's the way it looks in my brain. Since we're multiplying, I'm going to say, well, I have, and this is just kind of write this as your notes. All right, don't write it in the middle like I am. Write it off to the side. This is what your brain should think. I have 1 oxygen. I want that oxygen to multiply by something to make it be 2 oxygens, to make the list match. What's the answer to that equation? 2. 1 times 2 is 2. Now, some of y'all think I'm going kind of being baby about it, but it's good for your brain. I want that 2 to affect the product oxygen. The product oxygen is located right there. Where do I have to put the 2 to affect this oxygen? Right. Remember, you can't add subscripts. We can't add little numbers. We can't split a compound. The only way to affect that O is to put a coefficient in front of the entity that he's a part of. And then we need to alter our list. What happened when I added that coefficient? Well, watch. 2 times 2 is how many hydrogens? Now there's 4 hydrogens. 2 times 1 is how many oxygens? Which was the point. That's the whole reason that we did that. And now we look at our list again and we say, are we done? Why are we not done? Because when we fixed our oxygens, it messed up our hydrogens. Sometimes that happens, sometimes it doesn't. But now we're back to the drawing board. The oxygens are both a 2. The hydrogens are not. Which hydrogen am I going to fix? The reactant side. Ooh, she used a chemistry word. I like that. The reactant hydrogen. And it's the same question. This reactant hydrogen is currently a 2. I want that 2 to multiply by something to turn it into a 4, because that's what it is on the other side. What's the answer to this arithmetic? I want that 2 to affect my reactant hydrogen. My reactant hydrogen is located right there all by himself, which makes us happy. 2 times 2 is 4 hydrogens, and that's the only thing that'll change in my list. We're balanced. We're done. There's 4 hydrogens on both sides. There's 2 oxygens on both sides. Everything is balanced. Do you see? What number is right there? It's a 1. Don't put it. We don't show 1s in chemistry. But understand that it's not a 0. The reason that's a big deal is one last way to analyze this is you can look at what's called a mole ratio. And a mole ratio is very simply a comparison of the coefficients. For example, I would say that this balanced equation right here, all right, what I've circled in green is the answer. That's just our work. The mole ratio is 2 to 1 to 2. Very simple, but understand what I did right there. The mole ratio is 2 to 1 to 2. This says nitrogen reacts with hydrogen to produce nitrogen trihydride. Our job is to balance it. Step 1, reading off your cheat sheet, says to list the elements. I see 2 different elements. We've got nitrogen and hydrogen. Go ahead and separate this for our eyes a little bit. The reaction. Step 2 says duplicate that list. So draw it again under the product side. N and H. Step 3 says count. What are my numbers here? 2 and 2. What are my numbers here? 1 and 3. We cool with that? And now we compare the list and fix it with coefficients. Now, everything's jacked up on this one. All right, nothing matches, so you can start wherever you want to. Now, starting with the nitrogens would be fine. All right, if you multiply that times a 2 would go there, and everything will flow very nicely. I just want to pretend for a moment, though, just for teaching's sake, that we had to start with the hydrogens. All right, on this example, you wouldn't have to, but there's some that you might get in this situation where you have a 3 and a 2. So just so your brain can see the hopefully obvious solution. If I was going to fix the hydrogens first, I would say, well, I want that 2 to become a 3. But there's nothing I can do mathematically to make that happen without using a decimal number, which isn't okay. You've got to have whole numbers. Do you see the problem there? 2 times nothing equals 3 without a decimal. When you get into this situation, you need to find a number that both of them can turn into. It's called the lowest common multiple from 7th grade. But you need to figure out what that number is. Now, we'll always be dealing with very small numbers, so this doesn't get any harder if you can understand this one idea. What number can 2 and 3 both turn into? They can both turn into 6. So the question then is 2 times what is 6? 3. I want that 3 to affect the reactant hydrogen. The reactant hydrogen is located right there. Now, let's see what that changed. It didn't affect my nitrogen. That'll still be 2. 3 times 2 is 6 hydrogens. And that's all that's happened. Now let's finish our thought. Remember, we were tackling hydrogens. Over on this side, it's a 3 that we want to multiply by something to make it equal a 6. What's the answer this time? 2. I want this 2 to affect the product hydrogen. The product hydrogen is there. The only place I can put the 2 to make that happen is in front of the compound that H is a part of. Now let's update our list. The 2 is going to affect nitrogen. 2 times 1 nitrogen is 2 nitrogens. 2 times 3 hydrogens is 6. Are we done? We are. We're balanced. What is the mole ratio of my balanced equation? 1 to 3 to 2. Let me show you something else that can happen. Just try to give you all the little things you can run into when balancing equations. Write this down. One of the differences that this one has is sodium here is twice on the reactant side. So you've got to keep that in mind. For example, how many sodiums are there right there? How many? How many are there right there? So there's 1 there, 1 there. So how many sodiums are there on this side? There's 2. So you've got to watch for that happening, an element splitting itself on the same side. Step 1 is to list. How many different elements are there? There's 3. There's sodium, nitrogen, and oxygen. You see it? You see it? You see it? What do I do next? Duplicate it. Guys, the reason I use the word duplicate is you don't want to go over here and rewrite the list based off what you see. You want to write it just like this. If you write it based on what you see, you would write NaON, and you would swap the position of these 2 guys, which is fine, except your eyes suddenly have to do more work when trying to figure out if everything's balanced. So I just take this list and I just write it exactly the same. We already had this conversation. How many sodiums are there over here? There's 2. 1 there and 1 there is 2 total. How many nitrogens? Oxygens. Better be yelling at me if you don't like any of my numbers. Let's go to the product side. Sodiums, nitrogens, oxygens. Yeah? All right, let's have some fun. My sodiums are fine. Don't got to mess with them. My nitrogens are not. Which side will we fix for nitrogen? The reactant side. We always got to focus on the smaller number. The smaller number is a 1. We want to multiply that 1 times something to make it turn into a 2. In order to do that, we would choose a 2. We want that 2 to affect the reactant nitrogen. Look where the reactant nitrogen is. Now, we need to look at all the things this changed, because this changed quite a bit of stuff in a very annoying way. Let's see who gets a gold star. How many sodiums are there now? There's 3. There's 2 there, right? You see the 2. But remember, there's 1 there. So right now, we unfortunately have a terrible number of sodiums. All right? How many nitrogens are there? 2 times 1, there's 2 nitrogens. How many oxygens? 6. All right? Now, that did what it was supposed to do. Our whole point was to make the nitrogens equal, and we did that. All right? Let's move down to the oxygens. All right? I'm always going to try to mess with the easier numbers. Like the 3 and the 2, that's not very welcoming. But the 1 and the 6 is, because this is easy. Focus on the smaller number, which is a 1. We want to multiply that 1 times something to make it become a what this time? A 6. 1 times 6, beautiful. And this blue step I keep doing, you know, that's in your brain, really. If you want to write it down, but I'd like you to see what I'm thinking. We want that 6 to affect the product oxygen. The product oxygen is right there, which means the only place I can put the 6 is right there. Let's update our stuff. 6 times 2 is how many sodiums? 6 times 1 is how many oxygens? Now, our nitrogens are good, our oxygens are good. Now focus, I don't want this next part to blow your mind. Look, 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 look. Something really kind of funny happens here. We don't want to mess with that 2. Realize that if we mess with this 2, it's going to mess with everything, right? If we make that 2 something funky to make the 3 become a 12 for my sodiums, my nitrogen and oxygen numbers will change here, and then we get into an awful spiral of death while trying to balance this guy. But do you see that sodium? We can put a number there and totally not even mess with anybody else. So the nitrogens are good. The oxygens are good. How many sodiums are there just right here? There's 2. There's 2 of them right there. What's my total that I wish I had right there? What number do we want that to be? A 12. So ignoring everything else, if there's 2 sodiums there, how many sodiums do we wish were just right here? There was 10 there, 2 there, then there'd be 12 there, right? Now again, that was a funkier problem. It's my job to show you that sometimes you've got to think a little outside the box, but now we're balanced. What's the mole ratio? 10 to 2 to 6 to 1. Don't forget that 1. 10 to 2 to 6 to 1. Love it, hate it. I've been teaching this a long time, and I've learned that some of y'all are just really good at balancing equations, and some of y'all are awful at it for some reason. But if you're awful, you've got to get good, because then everything we're doing after this, if you can't balance, you can't do anything I'm going to teach you next week. So we've got to get good. You try one, and we'll be done for the day. We're on flex schedule, keep in mind. Write this down and balance it, please. Please don't shuffle. This problem looked intimidating. Your list is so long. All right, there's 3 chlorines on the left side and 1 of everything else. 1 iron, 3 of both of those guys, and then 1 of each of those guys. My ions are good. My chlorines are not. 1 times 3 equals 3. So I want to put a 3 on my chlorine here. Guys, look, listen to this. Don't change your list until you've added a coefficient. Don't say, oh, well, I want this to be a 3. What do I do to make that happen? No. It's a 1. It doesn't become a 3 till you actually do it. Then go back and change your list. Now there's 3 NAs and 3 CLs, and now we can move on. If you do it the other way, you're going to confuse yourself. Add the coefficient, then change your list. Good. No good. My sodiums are off. I want a 1 to become a 3. 1 times 3 will do that. Now there's 3 NAs. Uh-oh, this affected other stuff. There's 3 O's. And there's 3 H's. And suddenly this problem that kind of looked challenging has a 1 to 3 to 1 to 3 mole ratio. And we're balanced.